of us. From Sydney, Australia, please welcome Anthony Baxter.
So, yeah, hi. I decided today to talk a bit about what I call, there's a nice generic talk title of Pythonic APIs. And what I'm going to be talking about today is some good and bad examples. And on the subject of bad examples, I've always considered myself one of those. So, hi. I started with Python back in 92, 93, back when I was at uni. And yes, that makes me very old. Screw you. I've written a lot of Python. Really a lot of Python over the years. It's quite terrifying that a couple of years from now I've been using it for 20 years. This is back in 09 something, where anything that wasn't assigned to a value would automatically be printed to stand it out, like the interactive interpreter does. Back when it was very much a toy language. Back then, I remember dealing with Guido, and he wrote the very first web crawler. This is back in the very early days of the internet, back in the very early days of the web, and actually managed to crash web servers all over Europe by just writing a little simple HTTP crawler that just followed all links. Python's been around a long time. I've used it a lot and used a lot of different people's libraries. And so I thought I'd just share some things to do and not to do. One thing I will say though is Python's like a virus. It makes you want to get in there and spread it everywhere. You started a new job and you're like, oh, you use Perl, that's adorable. And a number of places I've worked at certainly go back to sort of mid-90s, and I'd start there and it'd be a Perl shop, and by the time I left there, it was a Python shop, and the people who left there went out and gradually spread it. At one point, you could trace pretty much everyone who used Python in Australia to either myself or Mark Hammond, who was the Windows Python guy, sort of by this sort of patient zero kind of thing between the two of us. Inevitably, once you start doing a lot of stuff with Python, you find bugs. The one important thing about bugs is the one question you do not ask is, cool, that bug is fixed, how long will it be a release? Because what happens is Guido says, congratulations, you're release manager. So 2.12, there was a particularly annoying, complicated, nasty little bug inside the interpreter to deal with what's called the trash can and the garbage collector, and it was causing our Zope service to crash. Yes, don't laugh, we used Zope. I ended up being a release manager for that micro release, and then someone else took over for the 2.2 release, and then it was like, well, there hasn't been a bug fix in a while, I'll step up and do it again, and suddenly I'm like the release manager, person, and I'm sort of the one going around yelling at the other developers going, you promised me you'd have this, or more often, no, you can't check that in, it is not a bug fix. One of the things I'm most proud of as being release manager was I brought in if it's a bug fix, it doesn't get new features. True and false, for example, were originally added in a bug fix release, and that was a nightmare, because it meant depending on which micro release of 2.2 there was, you might have true and false. This caused pain for everyone. Everyone had try, true, false, except name error, true equals 1, false equals 0. And you can still find that in code everywhere, old code. And that was one of the things I'm most proud of out of the time of release management, is actually bringing a bit of discipline to it. So we have a patch release every 6 months, as near as possible, and just basically systemizing it a bit. So I did it for about 5 years. I stopped doing it when I joined Google, because Google sort of has a habit of chewing up all your free time. That's just representative only, it's not actually how they do it. So, APIs. I've built quite a lot of them over time. I just thought I'd go through a couple to give you an idea. I actually wrote the very first database adapter for Python. It was a thing called MiniSQL back in the mid-90s, written by a guy up in Queensland. He did quite nicely out of it. I think HP ended up buying it for their network management software. It's now dead because SQLite just does everything much better. Because SQLite was written by someone who understood databases, whereas Bambi, God bless him, really just wanted something that worked and didn't necessarily understand the whole deep complexities of it. But he did a pretty good job of it. And MiniSQL was actually a pretty nice little embedded database for quite a while. This is well before the DB API and everything, so I just sort of made shit up as I went. It wasn't necessarily very nice, but it worked. Then I had a whole bunch of networking switches, and I wanted to actually monitor them. So I wrote a glue layer for the UCD SNMP library, as it became called, which was hand-coded C APIs. It ended up getting quite complicated because I then moved to an ISP where I was monitoring, network devices with 400 interfaces. So I had all this nice stuff to do parallel tree walking and really complicated stuff. It got a bit silly. I don't know if any of you remember a tool called Gadfly, written by Aaron Waters. It was a pure Python SQL database, and I actually back-ended the Gadfly front end onto an SNMP back-end, so you could do select star from device.interfaces.if table. It was kind of crazy. Stuff you do when you've got like a hammer and you go, ooh, I'm going to keep making this hammer. I'm going to add more blingy to the hammer. The other big one I did was called Stum, and we'll come back to that. And that was a voice over IP implementation in pure Python. I've done lots and lots and lots of other stuff. Sometimes I even get around to releasing it. Usually I just get bored of it before I even get to the point of releasing it, because I've solved the problem, I understand it. One of these days I'll go back through these CD-ROMs and DVDs of old home directories and just package up, like there's a BGP implementation in there and just all sorts of stuff like that I just, I wanted to understand it, so I wrote it and then went, cool, I understand it now. So how many of you here have actually built and released something on PiPI? Well, Jacob, obviously. Why would you actually do this? There's a few reasons. First one is you want to wrap some existing code. Python's really good at this. I've got a C library, but coding C is boring. It's just it's just keeping track of stuff. It's just stamping out number plates. So you obviously can use Python to do this, and we do this a lot at Google. Pretty much all of our big core scary C++ libraries are wrapped in Sweet, and you can do everything from Python. They do all of the magic stuff to deal with our distributed file systems and authentication and everything else, and you can do it straight from Python. This is awesome. You can write MapReduces in Python. I did that as in a talk I was doing about MapReduce. I wrote a MapReduce that ran in Python. I ran it over about, I think it was about a quarter of the internet, to compare how many times the word Anthony occurred on the internet compared to how many times the words Anthony followed by Baxter. Watch me do ego surfing. And I can't remember the number now. It was actually gratifyingly high. It was like about 1.5% of all references on the internet to Anthony's was me. So, and it was done purely as a, example talk. I think for an example talk about MapReduce, and I was trying to think of something, and I'm like, well, let's do ego surfing in a really hardcore way. The next type of APIs and libraries you tend to write, you've got something that needs to be done. You've got an itch that needs to be scratched. So you write the code, and hopefully if you're not like me and you're not as lazy as me, you'll eventually finish it and bundle it up and put it on PiPI so someone else can use it. The next place libraries often come from is they generalize existing code. If I understand correctly, that's pretty much where Django came from, because they had a specific bit of software they'd written, and they went, well, there's actually enough in this that would actually be useful for other people. So, rip out the specific bits and generalize it. And over time, libraries tend to become more general and more useful. And the reason I do it a lot is for learning. I've got a new protocol. As I say, back at an ISP, I was dealing with BGP. So myself and a couple of other engineers all had the same idea the same night and went home and wrote a BGP implementation. All turned up the next day going, hey, look what you did it too. And the final reason you write these sort of libraries is just for the sheer hell of it. This sounds like fun, let's write this. There isn't something out there to do that. And as a special subcase of that, I would call sheer bloody mindedness. Coming back to Stum, the original reason I wrote it was I saw one too many articles calling Python just a scripting language. So I wrote a talk, or I wrote Stum to basically be able to present one talk. And that talk title was Scripting Language My Ass. It was possibly a little bit overkill. I implemented SIP, which is a nightmarish protocol from the depths of Satan's butt. I implemented some IVRs on top of SIP, so interactive voice response. As part of that, obviously I had to do audio. I had to implement RTP. I had about 5 different audio capture interfaces for different forms of operating systems. It even worked on Gentoo sometimes. I had to implement, because firewalls screw voice over IP, I had to implement Microsoft's lovely universal plug-and-play. And Hodge, I will have words to you about that.
You already have.
Yeah, good. I have more. Universal plug and play is what happens when somebody who doesn't understand networking tries to implement a networking protocol. There's another one called Stun, which is an even nastier hack. Then I wrote a whole bunch of user interfaces and wrote a nice little general user interface layer on top of it. Again, you're just like, hey, here's a user interface toolkit I haven't implemented yet. You know, it's like, hey, there's no cursors interface, cool. And you know, again, it sort of went a bit silly. And then, of course, you implement Codex, and I ended up wrapping a lot of other existing C Codex because writing Codex is extraordinarily boring, and I've got much better things to do with my life. Really, I do, apart from all this, than to actually write a whole bunch of Codex. So I ended up wrapping just a buttload of them, including a bunch I could never release because they're all patented to hell. All the G720X patents, they're all, the code's available, but if you use it, they will sue you. Why the code is available is an open issue at that point. So yeah, it ended up being quite a... And then I implemented a TFTP client and server, and I can't remember exactly what... Oh, that's right, because the Cisco's all had their prompts served by TFTP, and I wanted to be able to get access to those prompts. It ended up being about 25,000 lines of code, which is, in Python, quite a lot. This was pretty much how I felt at the end of that, by the time I burned out on it. I just hit a point where it was like, nah, I'm terribly, terribly sick of this code base. It's still out there, and we'll come back to what's happened to that now, later on. So, what do I mean when I say Pythonic? I mean, the cheap and easy answer is, it's whatever Guido says it is. The reason I would maintain that Python has been successful is because Guido has excellent taste, in most cases. I mean, he ends up being mostly he's now sort of started to delegate that a bit to other people, but for a long time, he got to choose what went in the language, and it's a testament to, as I say, to his excellent taste that the language is mostly pretty good. The other way to express Python is the quote by Potter Stewart, I know it when I see it. I mean, in this case, he was talking about obscenity, but I think you can say, Pythonic is, it fits into the same thing. When you're using a bit of Python code that's been well designed, you know it, you feel it, it makes sense. And so what do we say when we say an API is Pythonic? And I would say one of the most important things is what we call the principle of least surprise, that it does what you expect. Methods have a name that actually, makes sense. I mean, the obvious counterexample to that in Python is dict.setDefault. Anyone who could have come up with a better name, I suggest you borrow Guido's time machine, go back to wherever it was we put it in, and come up with that better name, because God knows we couldn't. Another way of looking at what's Pythonic is, does it follow the Zen of Python, which is written by Tim Peters, one of the great old ones of Python. If you haven't seen it, import this. He is a great old one.
I'm not sure that that's a compliment.
I think he'd probably consider it a compliment. I think the first time I met Tim he was sitting at the back of a room at an IPC heckling Guido. I'm like, you must be Tim Peters. And of course there's that great quote, Python fits in my brain. A good API should also fit in your brain. Of course, coming back to that, as I mentioned, with setDefault, Python itself isn't particularly Pythonic. One of Guido's taste fails was definitely the map, filter, and reduce. Fortunately, map and filter have both been replaced by list comprehensions and zip, and reduce has been replaced by sum, because anything anyone ever used reduce for was adding numbers. It's true. We did an actual survey of hundreds of thousands of lines of Python, and there were like 3 examples of someone using reduce to not just add numbers.
They were multiplying.
No, I can't remember what they were doing something really nasty, like doing some sort of listish kind of whack problem. And of course, the real nasty is print angle bracket angle bracket. C++ is over there. And yeah, that's pretty much how I feel about the print thing. It's just awful. There is nothing good about that syntax, and thank God in Python 3 it's gone. I think that one is actually Barry Warsaw's fault. If it's not, we'll blame him anyway. And finally, of course, there's probably the word I still misspell the most, lambda. I always spell it landba. It's just, yeah. Anyway, so what are the sort of things you can, these are mistakes in Python, I would maintain. And plenty of APIs I've built and plenty of APIs I've used also have mistakes. So let's maybe go through a few of the common mistakes you might see. The number one mistake I would maintain in anything is being overambitious. You know, I'm going to take over the world with my new software. You know, just solve a problem. Don't try to do everything. And for God's sake, don't build a framework. Never. If you start off saying, I'm going to build a framework, yeah, you fail. Sorry, Jacob. You build a framework, but there is a point. And I'll come to why I dislike frameworks. I generally just want one bit of code to do a problem, solve a problem. You know, I just want something to read this particular file format and spit it out in a nice list of lists or list of tuples. I don't want to have to buy in to your framework. You know, the classic example of this is Twisted. Anyone who does a lot of stuff with networking protocols will usually hit a point where they're like, great, Twisted implements it. But the problem is that you have to buy into the whole Twisted mindset and the whole Twisted way of structuring your code to do this. Now, the Twisted evangelist will tell you, well, that's because you should do that, because it's the perfect way of doing it. Yet, I already have a whole lot of code. I don't want to have to rewrite it, or worse yet, spin off a separate thread just for this Twisted thing. Frameworks are the developer saying you will do your code in the way that I suggest is the best way to do your code. That means that up front you have to decide on the technology you're going to use to solve a problem. And that's always disastrous. Any time where the first step in solving a problem is to say, I will use technology X, you're in trouble. And an example of that is, say, at Google, we do interviews, we do problem-solving interviews. And one of the problems I have is a distributed systems solving one. The people who start with going, I would use ActiveMQ, and that's the first thing they'd say. And I'm like, you haven't even thought about what the problem is yet. You know, a lot of the time when you're trying to solve a problem, it'll take you 3 or 4 goes to figure out the right way to solve it. If you're having to buy into a framework, you're screwed. Because if that framework turns out to be the wrong thing, you've probably gone a lot further down the path, and suddenly you've got to back out. And what happens if you need to pull in a different framework that does it in a different way? You know, most of these frameworks don't play that well together. So I would suggest strongly, make sure your code can be used independently, little bits of it. Don't think about, I'm going to solve the world's problems with my beautiful design from the top down. Just do one thing and do it really well, and then extend out and take over the world. Mistake number 2, reinventing the wheel. Of course, it's a great, as somebody commented the other day, it's a great way to learn about how wheels work. It's also a great way to bore everyone. And in particular, if you build a web framework, I will find you. There are so many freaking web frameworks for Python. We already have Django, there's TurboGears. Between the 2 of them, there's a bunch of other smaller ones that have been around for a while. Don't build another one. Every time you build a web framework, God kills a kitten. Okay? And yes, you all know what they used to say and what it says underneath that text box. And anyway. And also, on the subject, if you build a templating language, I really will find you. Okay? There are enough templating languages out there. For the love of all gods in heaven, do not write a web templating language. Yes, it's a cool and interesting way to do it. But don't. Okay? Look, little kitten. He says, please don't build a web templating language. You wouldn't hurt that little kitten. Look at his eyes. He said, don't do it. Also, if you write an interface for Postgres or MySQL, you're just wasting your time. There are 6 interfaces for Postgres in PiPI. 6. Imagine how good the one would be if they all actually cooperated. And MySQL's probably got more. Really? Your needs are so specific, but not one of those existing 6? Or when the person wrote the 6th one, those existing 5? There was something they did critically wrong that you couldn't patch? That you had to write a 6th? Not one of those 5 people would work with you? I somehow doubt that. It just doesn't make anyone's life better. It makes your life harder because nobody cares about the latest and greatest templating language. And it makes the new developer or the developer looking on PyPI, makes their life hell because they go, I want a MySQL interface. Which one do I use? You know, what's the status of them? You end up going, well, which one's got regular releases? And you've got to drill down and just, no, please don't. The number three problem I see a lot, and I've certainly been guilty of this, complexity. This, of course, is an infamous PowerPoint slide that the US military used to explain, I think it was Afghanistan, and that's their plan for how they're going to like solve the political, socio-economic problems in Afghanistan in one convenient, easy to understand slide. Yeah, thank you. Yeah, thank you, PowerPoint, and all of, you know, well, I'm using Keynote, they're all the same thing. That mindset of just complexity. Yeah. Complexity means a steep learning curve. And not to pick on them and go back to SNMP, but PySNMP, this is a hello world in PySNMP. I'm not kidding. That is the minimum you need to do a simple set on a router. There's something deeply wrong. I mean, you can't really read the font, unfortunately, but there's something deeply wrong with a library where you need to write a couple of pages of code to get started. When I get a library, I want to be able to go in the interactive interpreter, import it, and start poking around with it, and get a feeling of it. I don't have to write 2 pages of code and then go, oh, wow, that was wasted. This is shit. This is another big one for libraries, being too clever. And again, I've done this. SNMPY. I don't know how many people know about SNMP. They have a thing called an OID, an object ID. They look something like this. You know, interfaces.iftable.ifentry.ifindex.1, and then there'll be ifindex.2 for the second interface. So I looked at this and I went, wow, I know what I can do. Get at it. It was a big, big, scary problem that I ran into really quickly. That's a full SNMP OID. Who can spot the problem there? Yeah, that's not an identifier, is it? So you end up then doing something like this. In a desperate attempt to maintain the purity of my get-at-her-based idea. And of course, worse yet, when you do this, and when you start overloading get-at-her, suddenly you start getting really horrible errors. Because it starts trying to look up, you know, the under-repr method on the router, and things like that. Python uses get-at-her for a reason. If you're really clever like that, there's so many libraries that do that, and I mean, I would point to acquisition in Zope as being the absolute classic example of this. It seems really clever, and then 3 weeks later you're sitting there going, I just want to kill myself. And then you sort of think, no, wait, I know who I want to kill, and it's not myself. Cleverness will chew off your face. It will also chew off the faces of all of your users. And see, there's one of your users, and it's having its face chewed off. Again, look at the kitten. Don't be clever. Also, on the subject, leave import alone. For the love of God, leave import alone. Please don't play games with module import. Okay? Yet you can, I've written it, you can write software to import modules from a URL and have them run. And have them run off the net, you know. But don't. Okay, just don't. It's stuff you do for yourself for fun to find out if you understand how import works. It's not something you release. Once you start getting bits of software where there's 3 of them, all doing funny stuff with, you know, magic importers, and then you're like, why can't you find this module? Why won't it import? Or I want to put this new module in. Where the hell do I put it? Because they're all doing magic, special, secret stuff, all pulling stuff from here and there and everywhere. And, you know, you end up having to run Python minus VV to see where it's looking. This is brutal and awful. And if you've got multiple bits of software doing that, your life just becomes absolute hell. So just don't mess with import. It's extensible enough in ways that are sane that you shouldn't ever need to do this. Oh, and while I'm on the subject, don't monkey patch the standard library. And people out there do it. Okay, this is what happens when you monkey patch the standard library. Cthulhu eats your soul. If you want to monkey patch the standard library, Ruby is over there. Okay? This is Python. We don't do this. So yeah, don't be too clever or cute. You know, just because you can abuse with doesn't mean you should. And this is a classic example. There's a module called with hacks. And I can't know if you can read that there, but there's a bit in there. This module is a collection of useful building blocks for hacking the Python with statement. Combines ideas from several neat with statement hacks. Several neat with statement hacks I found around the internet into a suite of reusable components. It's hacking with. What bit of reusable does the person not understand? What you do in the privacy of your own code base, of course, is entirely your own business. If you want to put something nasty in your own revision control system, great. Don't put it on PiPI or in a tarball that's available to anyone else. Keep your secret shame to yourself. That's why it's a secret shame. Yeah, please don't make it my mistake. And of course, the big one. And this one I see a lot at Google. We have Java, C++, and Python. People writing in the wrong language. You can write Python that looks like Lisp. You can write Python that looks like C++. You can write Python that looks like Ruby. You can do that. Python's extensible enough. But you shouldn't. You should learn the language. You can actually tell when someone's primarily a Java programmer. You look at their Python code, you can see pretty much, yep, this was written by a Java programmer. Don't port the APIs directly as a sub thing of that. If you've got a C library or a C++ library, you're probably going to want to do extra work on just wrapping the API directly, because these languages behave differently. They have different idioms to Python. So think about making it work in a way that feels natural. If you don't believe me, I would point to a couple of examples in the standard library. XML.dom. Now, XML.dom, I always like to think of the committee that did this as being like the dogs playing poker. They don't really know what they're doing and they really shouldn't be there. For example, to give you an idea of how XML.dom is, even JavaScript programmers don't like it anymore. They all use jQuery. It's like, if it's too bad for JavaScript programmers, for God's sake, use Elementary. It's in the library now. Just use that. Don't touch XML.dom. On the subject of import hacks, of course, XML.dom has the XML Plus package, which actually does all that. Monkey patched the standard library through import hacks, and that was the one that first came to mind as far as just nasty, nasty horribleness. Another example, of course, of the Java one is import logging. Hi, little Java guy. Somebody ported log4j directly, and it shows. It's a beast. I just want to log a line of text to a file. Why does this involve 4 factories, 3 classes? Put a line of text in a file. It's like, the first time I did it, I was like, screw it, I'm just going to use print. I ended up ended up actually just figuring out how it worked and got it working and done a nice wrapper and everything. But it's logging to a file. It should just work. And of course, import unit test, which is this direct port of the XUnit type things. I think, how many people have used a fairly large Python library out there of any sort, like Django or whatever? How many of those have their own wrapper around unit test? All of them. Because unit test isn't very good, and it's not very... it's getting better as we gradually move further and further away from the XUnit style of doing things into a way that's more Pythonic. But when you look at unit test, I think part of the idea was originally to be easy for people to go from different languages. But I would suggest that the cognitive cost from unit test, all this the amount of time people have wasted dealing with the fact that unit test was originally a Java thing, and it's from a language which actually needs patterns, because the language itself is so crap that you have to use patterns. Python doesn't need patterns because it's good enough to not need it. Python, of course, is not C and C++. It does, however, make an excellent wrapper around C and C++. One of the things about that is, as I said, provide higher level wrappers. Start off with your C types, your Swig, your Pyrex. If you really want, you can write a hand-coded C interface. I don't generally recommend it to people these days. There's just a hell of a lot of bookkeeping, and it's really easy to get it wrong with ink refing and dec refing and releasing the GIL and grabbing the GIL. There's just a lot of things you can get wrong. You use one of these wrapper generators. Any of them work. C types is in the standard library now, which makes it even easier. And of course, the great thing about using something like C types is somebody who wants to do development and who's on Windows doesn't need to mess around with compilers on Windows, which is always hell. They also have the advantage of being much more maintainable and readable because it's just Python code in general. Okay, with the exception of Swig, which is just this magic header file weirdness. But certainly the C types and the C types and the Pyrex code tends to be a hell of a lot more readable and a hell of a lot easier to understand. As I mentioned, though, provide a wrapper. We'll come to that in a second. And the classic example of the way I provide a wrapper, actually, we'll come to it right now, is PyGame and Piglin. They're two game libraries. PyGame is hand-coded wrappers around SDL and all the SDL code. It's quite slow-moving as a project. A guy called Alex Helkner in Melbourne, who's a friend of mine's brother-in-law, and Richard Jones's brother-in-law, and I think Richard's also involved in Piglin now. He originally, as a summer of code, rewrote PyGame as a C-types interface. The code was much smaller, it wasn't any slower, and it was much more maintainable. And they all went, oh, we kind of like our existing code, so he just sort of went, oh, well, sod it, OpenGL's cooler and shinier anyway. So he then took that, wrote stuff to generate bindings in C-types around pretty much all of OpenGL, and I think he also wrapped FFmpeg and a bunch of audio libraries and just massive amounts of stuff. So everything you could ever want to write a computer game in Python, and it gets used pretty much every time there's a Python game programming competition. You'll see most of the entries these days are using Piglin. And one of the things that he really got right in Piglin was wrapping all this low-level stuff and then providing higher-level interfaces around it. So you don't have to necessarily play at the raw OpenGL level. You don't need to go get the Red Book or whatever and actually read that and understand it. But at the same time, you can generally take the OpenGL examples on the net, do a little bit of a search and replace across them to switch languages and remove the semicolons and a few other bits and pieces, and it more or less compiles. So that's a pretty sweet bit of software. And if you're ever interested in doing game programming or user interface programming at a higher level, like most people at some point you decide to write your own slide presentation software. I think I've done that 4 times now. I now use Keynote because I'm lazy. Coming back to what I said before, Python's really not Java. And again, number one marker of that is any methods called getFoo or setFoo. That's a classic example of where, whoo, I spot a Java programmer, I'm going to mock you. And of course the other one is, and logging was I mentioned before, is the example of that. I'm going to have a factory build a factory build an interface. Yeah, what? No, don't. One of the examples I've used in the past at another talk was there's a method of code inside Wave, which is this project I used to work on, which actually has a templated class that takes 3 templated arguments, and then it has a static method in it called createFactory. It's not a factory class, it's a factory builder class. Your abstraction has just eaten its own tail and gone around and is, sort of chomped its way up to the head and is going to just sort of disappear into nothingness at some point soon. Method overloading is another big bad problem. People in Java are used to having 3 methods that take, different arguments. So what they do is they take one method in Python that can take any one of the 3 and switches on the type. Yeah, that sort of stuff just gets really horrible. Don't do that. And of course, heavy use of class method and static method is a real marker of a Java programmer that needs to be mocked. If you've got a static method, we have a name for those in Python, they're called functions. The only reason you need static methods in Java is because the JVM and the language has got missing bits. Everything has to be in a class. But in Python, there's almost no use for static method. Class method is good for alternate constructors, datetime.now, that sort of thing. I can't honestly think of a single use of static method in the time. Yeah?
So.
I can't think of a single good use of static method any time in the time I've been programming Python since static method came in. I really can't. It was just pretty much done there as a, to complete the set. I've got class methods, we may as well add static methods, but I really can't think of one. So how do we design an API? Having said all those, here's not what to do. shades of how not to be seen. But number one is have a use case. For all I've said, you know, I tend to build them as, even when I say, so the one I mentioned before, the BGP software, the use case I had was I wanted to build a route reflector, which is something that, BGP is the protocol used by the internet for ISPs to route between each other. A route reflector is a little device that connects to one of the core routers, and you can use it to query the routes without actually doing that on the core routers, which is always a bit scary. And you know, network engineers tend to be like, no, you can't have a login to my core router. It's doing stuff. It's doing routing. It doesn't need you running abstract little queries over it because you're curious. So I wanted to write a little route reflector that I could hook alarms and things into and do it all in Python. So that was my use case. And it worked out pretty well. Better yet, have multiple use cases. You'll start off with one, and hopefully you'll be able to come up with another use of the code, because that's about the point where you start, you know, it stops being a single application, and you start ripping the code out. Think about how it'll be used, obviously. And yes, that means thinking about Unicode from day one. I'm a big fan of the underscore equals std or upper. If they don't understand English, put it in uppercase and shout at them. But, you know, I'm just an annoying Australian and I don't speak any other languages. Well, Latin a little bit, but that's not very useful. So yeah, start off, you solve one problem. Start off simple. Don't over-design. This is coming back to the complexity and the over-ambition. You know, where you start off with a framework, just start off with some code. You know, get the stuff done, even if it's one giant function. Strongly, I have some issues with the Agile community. Kool-Aid drinking, but yeah. Yagni, you ain't going to need it. Don't write it until you need it. Maybe put a hook in there or a hash to, you know, comment with to do. Maybe consider putting this in later. But don't necessarily worry about writing it all at once. Solve that one problem up front. You know, there's so many bits of PiPI code out there that don't even solve one problem well. Releasing a bit of code that even if it only solves one problem really, really well, and it's a really specific problem, the internet's really big. There's a lot of Python programs. You're unlikely to be the only person to ever have that problem. Once you've done that one pass, do a pass over it. Which bits of the code look good? Preferably leave it a week or so. Come back. Now solve a second problem with it. Or if you haven't got a second problem, chase around people in the same community. Ask them to try. You know, ask a friend to do it. They're like your user interface. If you're doing user interface design, those first couple of people you give your code to, they're like your early beta. Yeah, they're like your early UX testers, your early user experience testers. See what they say. If they come back laughing and, you know, mocking you, and you maybe pants you or whatever, it probably means you've got some work to do. But ask them, you know, what worked, what didn't. And of course, you have to be ruthless with early refactoring. Throw shit away all over the place. Because as soon as you get users, that stuff becomes much, much harder. Always just keep building on it. Be generous with accepting things. Build on what's in Python. If you've got something that's a result set, it makes perfect sense to make it act like a list. Give it an iter method. So people can just go for I in blah.query. And again, dict sets. Don't be smart. Don't be too smart. Duck typing is great, but ducks are well known for being sensible. Really, they are. I promise they are. Remember what I said before. Get attr and set attr. Don't ever use get attr and set attr. If you build a class that has get attr and set attr, you're a hazard to yourself and a danger to others.
What is duck typing?
Duck typing means, duck typing is Python's approach to typing, which is, I don't need something to be a file. I need something to just implement enough of the file interface. And it comes from the concept of, if it looks like a duck and it quacks like a duck, it's a duck. And this is how Python works. I don't need something that's a file object. In this bit of code, all I need is something that has a read and a close method. The fact that it happens to be a HTTP result object with a read and a close method, that's great. I don't care. I can pass it to something that expects a file. I can do a HTTP get and pass the result object into something that expects a file to read from, and it'll just work. But again, you can get overly clever. And I've certainly done it enough, and don't, because it will bite you. And getter and setter is the classic example. Python does a lot of magic internal looking up attributes. A lot of those go through the getter and the setter. Setter in particular is a great way to obscure errors, as is getter. So you just be really careful about using those ever.
How about using that with the property decorator?
You don't, well, property decorator with getter? No, not getters and setters, but getter, which is a special.
I know.
I'm trying to understand what you mean.
With the property decorator, you can sometimes do something when, for example, setting, but on the getting just...
But that's still, you've got an explicit method and an explicit property.
Yes.
I'm talking about a general set-atter, which catches every other set. Allow you to set any parameter, and whatever parameter you set, I will write that off to a database or something like that. That stuff gets nasty. There are use cases, like in ORMs and the like, where you do need getter, but you've got to be really specific and really careful, and they should always be, a whitelist of things they will actually respond to, and otherwise they'll return attribute errors. A getter or a setter, but except the world, at some point that's going to bite you so hard. It's that's where you're starting to get into the same sort of territory as JavaScript with its undefined object. I think Perl has a similar undef or whatever it's called. This stuff is nasty, and this is not Python, and it will hurt you. I promise you. So you start with a bunch of functions. This is what I tend to do. It's just whack a buttload of code in a single module. It does the problem. Don't over-engineer it. Then I do a pass over it and go, look, there's some replicated code. Cut it out. The next step is to start thinking about testing it. And yes, you can all laugh at the spirit of Australia. Damn you Kiwis. Technically, I think that's a French engine, though, so, is it French or British? British. Even worse. I learned testing the hard way. I mentioned before about Sturm. One of the reasons I gave up on Sturm is SIP. SIP is incredibly complicated. By incredibly complicated, I mean really. The core RFC for SIP is 269 pages long. There are at least 8 to 10 of these sort of little, you can't really, unfortunately I should have bolded it, it's little sort of ASCII art state machines. SIP pretends to be HTTP. It's not. It's wearing a little HTTP hat and going, look, I'm HTTP. No, you're not. You're text-based and you use some of the same syntax. It's a beast. As I mentioned back here, Sturm SIP support was one giant long spike. It's an agile term for just churning out the code, not worrying about is it refactorable, is it testable, just get it working. And it was hundreds and hundreds of lines long, this file. It was like 700 or 800 lines long. And a big comment across the top going, don't look at this, it will burn your eyes out from horror. And it just killed me. One of the problems was I actually was just implementing it off, here's some packets that are coming in. I think I'll do this, rather than trying to implement it. Because I looked at the 269-page RFC and went, boring. I'll just implement it off what this little voice over IP phone does. That was actually a bad mistake, but the worst mistake was it had no tests, and it wasn't testable. One of the things I've learned over time, particularly at Google now, where testing is so much more important, and it's not sort of an optional thing if you want to get code checked in. Testing is good. Yeah, we all know that. Motherhood, apple pie, American flag, New Zealand flag, kiwi fruit, pavlova, whatever. The mighty kiwi soaring majestically, or I don't know. They do that? No, they don't do that. Scuffling majestically. But it turns out testing actually makes your APIs a lot better. One of the reasons for that is if you test using mock objects, a mock object, you say on a mock, you should expect to get this call, and when you do, return this, and then expect to get this call, and when you do, return to get this, and there's things like you can say, you should expect to get this call 5 times, 4 times, return true, and the 5th time return false. There's a bunch of different mock libraries out there. It's a really nice way to do this. But once you start doing this, and you've got your duck typing, suddenly your code becomes a lot more testable, a lot more usable. because you're having to break it up into nice little pieces. And it means that if somebody else comes along and goes, this does 90% of what I want, but that other 10% isn't there, they can just import your code and override that one method that does, oh, actually, I want to read it from a network port rather than from a network interface, or from a HTTP server, rather than reading it from a local file. And all they need to do is override that one little bit of code that does the open. And once you start getting heavily into the mock-based testing, you start finding, actually, it's easier to break my code up to test the little components. And this was a kind of bizarre thing for me, because I always considered testing being sort of a necessary overhead. And it had never really occurred to me until a couple of years ago that it actually makes your APIs a lot better. It's like another use case for your APIs. So I'd highly recommend, I mean, I use one called MOX, M-O-X. As I say, there's probably about as many mock libraries as there are MySQL frameworks. But in their defense, it's still pretty early days for mock frameworks, so hopefully over time they'll start stealing the best ideas from each other. People, as I say, people find new ways to use your code. So when you've got those nice, easy-to-use components, or nice, easy-to-use modules with nice, easy-to-use methods that can easily be overridden if necessary, then it makes everyone's life easier, and people can come along and go, hey, this just works. And then you can ship a different version of it. You know, for example, Beautiful Soup, the library. When I was doing the universal plug-and-play code, I wanted something to parse soap, so I just did some brutal overriding of bits of the internals of Beautiful Soup to produce Beautiful Soap, which would parse XML. I still think that's the best name ever. I ended up replacing it with a much simpler library called Soap Sucks, which I wrote myself. Oh, by the way, with that side of things, don't rely on underscore methods to protect you. You know, this is underscore foo. You shouldn't ever use it. You shouldn't ever play with it. It's protected. And if you use double underscore method, no, don't. Double underscore methods are a really nasty hack. Again, one of those Guido taste fail things which does namespace hacking. It's only useful for protecting you from accidentally overriding things. It doesn't actually protect your code. It just means the person who does have to override your code has to do a little bit extra work. There's been cases in the past, I think it was the email library at one point, had an underscore method, which you actually needed to override at all sorts of times and places for various things. And so we actually ripped that out. It was one of those things you go through and just go, no, just kill it. Kill all underscore methods in the standard library. And I went through a while back and killed all double underscore methods in the standard library. Just did a grep across the entire code base and just went, they all die. They're a bad idea, and the standard library is a kind of supposed to be, you know, a best practices example. It often fails at that, but we can at least try to make it better in little incremental steps. All of your API is public, okay? All of it. You just have to assume someone's going to take it and override that underscore method. This may or may not be a problem. If you've got people paying to use your code, it's often more of a problem. App Engine, we've had this problem, where a lot of our API is now fixed. We had to do a rollback of a release at one point because we'd actually changed or removed an underscore method. And a bunch of our customers had actually, Google's customers, had actually been using that underscore method and overridden it or calling it directly, and it broke their apps. And they're giving us money, so, you know, they win, as much as we, you know, it offended us. Python's ethos is everyone's a consenting adult. Consenting adults get up to some really twisted stuff, okay? Let them do that, just don't look. Just, you know, okay, whatever, yeah. Or, you know, your kink is not my kink, but that's okay. I believe is the usual term in the sort of the various communities like that. The best you can do is say, in your comments and whatever else, here be dragons, and hope that whoever abuses the internals of your library gets eaten by one of these dragons. You know, Smog, I think, is the one you're all going to get familiar with in New Zealand. So quickly, how do you make your API popular? You've written all that code. Number one, documentation. Absolutely. Anything is better than nothing. Any documentation, a README that says, here's a quick start. You can even generate it from doc strings if you must. Once your code gets bigger, again, going back to logging, at one point all logging had in the thing was a complete reference to all the classes, and it was like 8 pages. and you're reading it just screaming, I just want to log to a file. So I added a page at the end of that. It was kind of a bit of passive-aggressive, you know,